What is stuff? What is stuff? Well, stuff is stuff. It's very stuffy, stuff-like, stuffish, stuffing. Mmm, stuffing. But here's the question. What is stuff? Well, first, let's talk about some basic stuff. Stuff is made of atoms. Atoms are really small, and they make up everything from the bedpost to the blankets, the door to the floor, me to you. Different atoms are different from other different atoms because there are different elements. An element is something that cannot be broken down any more into different substances. Basically, atoms are the building blocks of absolutely everything, and they come in over 100 different elements. Elements, as I said, can't be broken down into different things, but they can certainly be put together to make different things. Let's take an element. I'm sure I've got one around here somewhere. Oh, let's see. I found one. Hydrogen. This is a great example because it's a nice, simple element, but it still has all the components that you need. Now, it has one proton, a positively charged subatomic particle. A proton, the fact that it has one proton, is what makes hydrogen hydrogen as opposed to something else. You see, that's the difference between different elements, the number of protons. 2 protons, for example, would make the element helium, which we use to fill balloons. 3 protons would make it the element lithium, which is useful in batteries or medicine. But back to hydrogen. Like I said, this hydrogen has all the basic components of an atom. It also has one neutron, a subatomic particle with no charge. In an atom, you'll generally find that you have one neutron for every proton, but not always. Changing the number of neutrons does not change the element, but it does change the isotope of that element. And the more neutrons you have in an element, the more unstable it is. Lastly, we have this negative subatomic particle called an electron. Electrons are highly variable, easily lost and gained. They control the charge of an atom, and they're also very important for our next topic, bonding. This discussion should be a good bonding experience for us, eh? Eh? All right, moving on. But first, quick review. Stuff is made of atoms. Atoms come in different elements. Elements are determined by protons, their isotopes are determined by neutrons, and their charge is determined by electrons. Good? Good. Now, let's say our hydrogen is joined by another hydrogen. Both of these hydrogens have something that the other one wants, another electron. You see, though atoms don't have brains and therefore can't really want things, there are certain natural rules they tend to follow. So we can say an atom wants something as it tries to follow these rules. For example, atoms want complete valence shells or a complete outer layer of electrons. The first valence shell of an atom only needs 2 electrons, so each of these hydrogens only needs one more electron to complete its valence shell. Now, like I said, electrons are variable, so you may wonder, why not just pick up another electron of its own and have 2? Well, this would make it have a negative charge, more negatively charged electrons than positively charged protons. And that's something atoms want to avoid, non-neutral charges. So the better solution? These 2 hydrogens should just share. Sharing is caring, friends. This is a phenomenon known as covalent bonding, and it makes a new something called a molecule. This is a fairly simple molecule, and it's also pretty common. You're more likely to find hydrogen paired with another hydrogen than you are to find a lone one. There are lots of other molecules with lots of different makeups. There are a few more like hydrogen that can pair with themselves, or even make a giant group of just one element. For example, carbon, which you can find in huge groups of carbon atoms joined together in diamond or graphite. But there are far more molecules made up of different elements combined, and these are called compounds. A good example is H2O. Now, in this molecule, two hydrogens decided to help an oxygen fill up its valence shell. And now all three of them are sharing electrons. H2O is a pretty important compound. Water. Who knew that hydrogen, a gas, and oxygen, another gas, could come together to form such a life-giving liquid? Well, it's very common for a new compound to be completely different from the component elements, so it's not as surprising as you'd think. Now, let's talk about a different kind of bonding. Ionic. Sometimes atoms don't share for special reasons. Like this sodium. You see, this atom could really care less about this one electron it has in its valence shell. It's so far from filling up that it would much rather just lose this one. So, when chlorine comes in asking for one, sodium doesn't bother sharing, it just hands the electron over. Now chlorine has just filled up its valence shell, and sodium has cleared its near-empty shell to reveal a full one underneath. Everybody is happy. But remember when we talked about charge? Well, losing that one electron made sodium have a positive charge, and that electron chlorine gained made it negative. Well, those opposite charges attract, as opposites tend to do, and they end up bonding ionically. They're not quite as close as two covalently bonded atoms, because they're not sharing electrons. But they're each fully satisfied with the new compound, NaCl, and it is a neutral molecule overall, with one positive atom and one negative atom, whose charges cancel each other out. Now, as you may or may not know, NaCl is actually the chemical makeup of what we know as salt. Well, now we've talked about salt, and we've talked about water. What about salt water? Well, salt water is an example of what is known as a mixture, which we'll talk about in just a sec. First, another review. Atoms can bond. They can bond covalently, by sharing electrons, or ionically, by developing different charges that cause them to be attracted to each other. When either of these bonding types occur between two or more different elements, you get a compound. Good? Good. So, what's all this about mixtures? Two or more kinds of molecules/atoms get all mixed up in one another to create a new substance with properties of both. Note, this is different from bonding. Though the molecules may interact, they do not connect in the same way that two bonded atoms do. There are also different kinds of mixtures, heterogeneous and homogeneous. Salt water is an example of a homogeneous mixture, one where two or more molecules/atoms are completely mixed and you can't pick out one or the other. It's all salty, it's all watery. It's hard to separate or distinguish between the two components. A heterogeneous mixture, by contrast, has components that are not so thoroughly incorporated that you can't see the difference. Now, let's say you took a bunch of red Skittles and a bunch of green Skittles, and you mixed them together. Well, it's true you've got a mixture, but you can see where you have red Skittles and where you have green. Not to mention, it's not very hard to pick out all the greens from the bowl or all of the reds. Basically, a homogeneous mixture is one that you can't pick apart, and a heterogeneous mixture is one that you can. Anything that only has one kind of element or one kind of compound, and therefore isn't a mixture, is a pure substance. One last review. Let's go for it. Mixtures are made up of more than one molecule or atom all mixed up together. Homogeneous mixtures can't be separated into their components, but heterogeneous mixtures can be. Something made of only one kind of molecule or atom is a pure substance. Well, there you have it. Elements, compounds, and mixtures, just about all the stuff that makes up stuff. I hope you enjoyed this video, and I hope you learned a little bit. Bye!